Hello everyone. Actually, in previous one of the video, I already discussed about the TPM. So I thought today I want to discuss with you regarding the TPM related calculations. I think you know TPM. TPM means total productive maintenance. Some people call this total productive management also. So when we going to implement TPM, we want to know about the TPM as well as we want to know about the TPM related calculations. When we talk about TPM related calculations, there are mainly four terms. Now you can see that those four terms. The first one is OEE. So what is mean by OEE? OEE mean overall equipment efficiency. So that is one of the major calculation when we talk about the TPM. The second one is MTBF. MTBF means mean time between failure. So mean time mean actually average time. Then the third one, MTTR. That means mean time to repair. Mean time to repair. The last one, MTTF. That means, okay, mean time for the failure. Mean time to failure. Actually, we want to know the OEE, MTBF, MTTR, we can calculate. The MTTF, we can't calculate, we have to record that data. I'll explain that in the next slide. Okay, so we are going to talk about during this video OEE calculation, mean time between failure calculation, mean time to repair calculation. And this is not the calculation, this is we have to record. So we will discuss a little bit about the MTTF also. Right. Now you can see MTTF. MTTF means lifespan of non-reliable assets. That means, okay, when new machine installed, okay, from the install day, when the first breakdown happened, the duration we can call MTTF. As example, if this is install day, if this is the first breakdown happened, okay, first BD happened. So this duration, okay, from install to first breakdown happen, that is we call MTTF. So that is why I told you previously, this is we can't calculate, but install date we can record, then first breakdown happen date we can record. So based on that, we can identify what is the MTTF value. But MTTR mean, okay, it is mean time to repair. That means when the failure happen, at that time we start the repairing activity. So after start the repairing activity, next time again, when we start the operation, that duration we call time for the repair. So when we talk about particular day, there can be several repairs. So we have to calculate the mean time to repair. Mean average time for the repair. So after we repair, now machine is running. This is called the running time. Okay. So what is called that usually machine running, again breakdown happen. After some period, okay, we are complete the repairing activity, then again running like that. So this is, okay, mean time between failure. So before the failure, what is the running time? Okay, that is we can put into that mean time between failure calculation. So mean, we are taking the average also of that parameter. Okay, now I'm moving to next slide. Okay, right. Now you can see here, this is the operation initially start time. T1 time we run the machine, then breakdown happen. This cross mark illustrate the breakdown. When the breakdown happen, again we start the repairing activity. That repairing time duration, it's mentioned by using that blue color TA time. After repair, again we start the machine. Then we run the machine T2 time. After the T2 time, again breakdown happen. Okay, again breakdown happen. Then again we repair TB times. Okay, now it is ready to run. Again T3 times we run the machine. Again breakdown happen. So we repair TC time. Okay, again machine start the work. Now this is T4 running time. Again breakdown happen. Then we complete the repair by using TD time. So you can understand now that red color things, okay, this is machine running time. T1 time run, T2 time run, then T3, T4. So if you want to calculate mean time between failure, that means machine running time, average machine running time. So it is called MTBF. This is the equation you can understand. Okay, summation Tn from 1 to n divided by n. That means according to this example, we ran T1 time, then we have to add T2, we have to add T3, we have to add T4. T1 plus T2 plus T3 plus T4. This is the running time. So what is the what is called that number of running times? Okay, there are 4 slots. So we have to divide by 4. Then we can take the average time between failure. We are calling that mean time between failure. Then the second one, you can understand the TA, TB, TC, TD, that blue color times. Okay, those are the running time. Sorry, those are the repairing time. So it is called mean time to repair. TA plus TB plus TC plus TD. There are 4 breakdown happen. So because of that, we are dividing by 4. So it is called average time for the repair. If not according to the TPM, we call that mean time to repair. So I think it is very clear how to calculate mean time between failure and mean time to repair. Okay, this is one of the example. Now you can see some machine, okay, ran 5 days. After the 5 days breakdown happened, 10 hours we have to repair that. After repair, again 10 days run, okay, then breakdown happened. 20 hours repair we have done. Then 20 days run, again breakdown happened. It was 10 hours repairing time. Then 5 days run, again breakdown happened. 25 hours repairing we have done. Then 10 days run. So, okay, 15 hours repairing time we have done. So now we want to find out, okay, what we want to find out? We want to find out mean time between failure. That means average working time. In here, 5 days, then 10 days, then 20 days, 5 days, plus 10 days. We can't consider these 20 days because it is not mentioned the next failure. So we don't know after 20 days it will fail or it will take 30 days to fail. We never know. So we can't take this number. So what is the working time, total working time? Okay, 5 plus 10 plus 20 plus 5 plus 10. That means, okay, 50. So when we take the mean value, mean average value, we have to divide by 5. Why we want to divide by 5? There are 5 occasions. Okay, so what is the average time between failure, if not mean time between failure? 50 divided by 5, that means 10 days. So MTBF is 10 days. Now we want to find out, okay, mean time to repair. What is the average time taken for the repair inactivity? Mean time to repair. Okay, you can see here 10 hours, 10 plus 20 hours. It is mentioned in this round shape. Okay, inside the round shape, the time mentioned. Then 10 hours, then 25 hours, and 15 hours. So altogether, we have to add these repairing time. Then there are 5 failures. So because of that, we have to divide this by 5. Okay, so when we add all these numbers, 10 plus 20 plus 10 plus 25 plus 15, it is 80. Divide by 5 mean, okay. So mean time to repair, average time taken for the repair activity is 16 hours. 16 hours. So now I think you can calculate mean time between failure and mean time to repair without much more effort. It is very easy thing. So mean time to failure, if we can't calculate it, we have to record. Please keep in your mind. Right. Now I am moving for OEE calculation. What is mean by OEE? Already I have mentioned in previous time, overall equipment efficiency. Okay, when we calculate overall equipment efficiency, this is the basic equation. The simplest way to calculate the OEE is as the ratio of fully productive time to planned productive time. So simple equation is, okay, what is the simple equation? OEE equal fully production time productive time, fully productive time divided by planned production time. So usually we are taking OE as a percentage, so we have to multiply by 100. This is the simplest form of equation, simple form. Okay. So fully productive time mean, okay, how we can calculate the fully productive time? Fully productive time we can calculate equal good count. Good count mean number of good pieces which we have produced. Good count multiply by idle cycle time. Idle cycle time mean time taken to produce one piece, one product. So by using this equation, we can find out the fully productive time. So that means overall equipment efficiency equal fully productive time divided by planned production time multiplied by 100. So we can replace fully productive time by using good count into idle cycle time. Then OE equation become OE equal good count. That means number of good pieces produced multiplied by idle cycle time. The answer divided by planned production time. And when we multiply by 100, we can take the answer in a percentage form. There is example in here. Cycle time 60 seconds. Good count, number of pieces, good piece produced 50 pieces. So planned production time 1 hour. That means this is mentioned in a second. So planned production time also we have to mention in a second. Then OE equal, okay, number of good pieces 50 multiplied by cycle time 60 seconds divided by planned production time is 3600. So we have to multiply by 100. So overall equipment efficiency is 83%. 83%. Okay, right. There are 3 examples in here. We'll see. Okay, cycle time 30, good count 100, plant production time 3,600. Then how we can calculate? Okay, OEE equal OEE equal good count, number of good count, 100 multiplied by the cycle time, 30. This answer we have to divide by plant production time, 3,600. Then finally, we have to multiply by 100 because we want to take this from percentage. So we are multiplied by 100. So what is the answer? 100 into 30. Okay, so I am simplifying. 100 into 30 mean 3,000. So 3,000 divided by 3,600, then multiply by 100. So what is the answer? Okay, we'll take the answer. 3,000 divided by 3,600. Okay, so 0.83 into 100, that means OE equal 83%. 83% in here. We'll see the next question. OE equal, okay, number of good parts, how much? 25 pieces. What is the cycle time? 90 seconds. So we have to divide by plant production time is 3,600 multiply by 100. Okay. So when we solve this one, 25 into 90. What is the answer for 25 into 90? Okay. 25 into 90. Okay. 2,250 divided by 3,600. Okay. Then multiply by 100. So answer is, okay, divide by 3,600 mean 0.625 into 100. That means overall equipment efficiency is 62.5%. Now we are coming to the next question. Okay, then OEE equal, okay, in here the good count is 200, cycle time is 10 seconds, divided by plant production time 3,600. Okay, we have to multiply by 100. Then what happened? Okay, 2,000 divided by 3,600 multiply by 100. So what is the answer of OEE? Okay, 2,000 divided by 3,600. That means 0.56 into 100. Okay, so overall equipment is, as a percentage, 56%. So I think overall equipment efficiency, that simple calculation, now everyone can do. It is very easy. Okay. So I'm moving to next slide. Although this is an entirely valid calculation, now already we have calculated the OE, that is entirely valid. So anyone can't tell that is wrong. But the thing is, okay, that is not provide information about 3 loss-related factors. When we talk about the TPM, there are 3 loss-related factors. What are the 3 loss-related factors? Availability, that means machine availability, then machine performance, then the quality of the product. Those are, we call 3 loss-related factors. So when we calculate the OEE, we want to add all these parameters. Because of that, we have to change, okay, because of that, we have to change the equation a little bit. Then, okay, OEE, overall equipment efficiency, we are going to calculate availability multiply by performance multiply by quality. Okay, that is the complex model. Complex means not the complex, but when we compare in the previous method, it is very easy. We calculate only the performance part, only the performance part. But we have to calculate the availability part as well as the quality part also. Okay, so I'm moving to explain about you availability. Then this is the equation for availability. Availability equal runtime divided by planned production time. Then how we can calculate the runtime? Okay, runtime we can calculate. Okay, runtime mean runtime equal planned production time minus stop time. Stop time mean maybe breakdown. There is example in here. Planned production time is 8 hours. Stop time already given 0.5 hours. So we have to calculate the runtime. How we can calculate the runtime? Runtime equal planned production time minus stop time. So that means 8 minus 5, 7.5. So availability equal 7.5, that means runtime divided by planned production time, that is 8 hours. So 0.9375 is the availability. Now we have to find out the performance. What is the equation for performance? Performance equal idle cycle time into total count divided by runtime. So idle cycle time is 30 seconds, total count is 50, runtime is 3600. So performance equal 30 into 50, idle cycle time into total count divided by runtime. Then the answer came 0.42. Now already we calculate availability as well as the performance. The last one is quality. Quality equal good count divided by total count. Okay, good count is 50, total count is 55. So quality 50 divided by 55 means 0.909. So in here you can see overall equipment efficiency, availability multiplied by performance multiplied by quality. So this is the equation for availability. It is 0.93, then the performance 0.42, then the quality is 0.909. So when we multiply all these things, the OEE, the answer came 0.35. When we multiply by 100 to present in percentage form, then it is 35.79. So this is the complex model of overall equipment efficiency calculation. There is example in here, already given the equations. We'll see, okay, there is a data, there are several data included in here. So we have to calculate the OE. So first we have to calculate the availability. Availability equal runtime divided by planned production time. In here, shift length is 8 hours, 480 minutes. But there are 3 breaks given. 15 minutes, 2 break given, 30 minutes, 1 break given. So because of that, even the shift length is 8 hours, already we plan 1 hour break. Okay, 15 into 2, 30 minutes. In here, another 30 minutes. So we are planning 1 hour break. So what is the planned production time? So because of that, planned production time equal, okay, 480 minute minus 1 hour breaks, all the breaks, 60. So answer is 420. So planned production time is 420 minutes. Then runtime. What is the runtime? From that planned running time, 47 minutes it was downtime. So because of that, actual runtime is, plan is 420. We have to reduce 47 minutes. That means 373. 373. So planned production time 420, runtime 373, then availability equal runtime 373 divided by planned time 420. So what is the answer? 373 divided by 420, 0.89. This is the available time. Availability. Then performance. Performance. So what is the performance? When we calculate the performance, idle cycle time into total time. Idle cycle time given 1 second. Okay. So 1 into, what is the total count? How much total count in here? 19,000. Okay. 19,271. That we have to divide by, okay, runtime. Runtime is 373, but the what is called idle cycle time given in second, the runtime in here given in minutes, so we have to multiply by 60. Then performance, the performance 19,271 divided by, okay, what is the answer? 373 into 60 mean 22,003. Then performance related answer, okay, 19,271 we have to divide by 22,380. So answer is 0.86. Already we have calculated availability and the performance. Now we have to calculate the quality. So quality mean good count divided by total count. So what is the good count? Total count is 19,271. So 423 reject. So we have to minus 423. Then we can find out the good count divided by total count. Okay. Then how much the good count? 19,271 minus 423. So what is the good count? Good count equal, okay, good count equal 18,848 divided by 19,271. So what is the answer? So what is the answer? Answer is, okay, 19,271. That means 0.97. So overall equipment efficiency equal availability multiplied by performance multiplied by quality. So what is the answer? Availability is 0.89 multiplied by performance 0.86, quality 0.97. So final answer is, okay, please calculate 0.89 into 0.86 into 0.97. So the final answer is 0.75. If not, OEE equal 75%. That is the calculation. So it is also very easy. I think now you can calculate OEE through the complex model also. Okay. So finally, I would like to say, okay, when we talk about the TPM, we want to know about the TPM related theory, as well as we want to know about what is that TPM related calculation source. There are few types of calculations. Okay. What are those calculations? We have to understand mean time between failures. We have to understand mean time to repair. Those things we have to calculate. We have to calculate. Already I have discussed this part. Then OEE, we have to calculate that one. We have to record mean time to failure that we have to record. So those four are the main numeric, what is called numeric related things when we talk about the TPM. So I think now you may have some idea about the TPM calculations also. So I'm expecting to do another video regarding the insight of TPM also. So please hoping for that also. So we'll meet again. Till that, thank you very much. Have a nice day.